The number 8 here is also indicative. We may have 9 or 10 directions, and also we can have 6 or 7 directions only, depending on how we classify these directions. For example, the quantum AI may be considered as direction number 9, or it can be distributed over some other directions. In reality, quantum AI is a kind of artificial intelligence which is related to quantum physics, to some laws in nature. Quantum cryptography, which is part of quantum AI, takes its power from some physical laws. One of them is quantum entanglement, the fact that information goes from particle to another one instantaneously without propagating in a medium like vacuum or air. Therefore, it cannot be intercepted by intruders. In other words, quantum AI has its power in artificial intelligence, but also in physics by using the quantum laws.
Specialized AI. The first strategic direction in the evolution of artificial intelligence is what we call specialized AI. Unlike general-purpose systems that attempt to perform a wide range of tasks, specialized AI is designed, trained, and fine-tuned to operate within a specific domain. It is built for depth, not breadth, and this focus brings substantial benefits. Specialized AI models are trained on domain-specific data, which improves their ability to detect relevant patterns. Optimized for narrowly defined tasks, which reduces errors and increases processing speed. Easier to evaluate and validate, since their performance can be benchmarked against well-understood metrics and operational scenarios. In terms of our 15 performance conditions, specialized AI directly aligns with Condition 3, specialization; Condition 6, access to large volumes of data; Condition 9, correlation analysis; and Condition 10, fast computation and analytical processing. To illustrate its impact, consider one of its most important application areas: medical image diagnosis. In this context, a specialized AI model may be trained exclusively on thousands of annotated radiology images, such as MRIs or X-rays, with input from expert oncologists. This model can learn to detect subtle anomalies that may signal the presence of a tumor, prioritize cases with high-risk features for rapid human review, and operate at speeds far beyond human radiologists, enabling quicker intervention. Such models do not attempt to diagnose all medical conditions or handle every imaging modality. Instead, they are precisely targeted, yielding high efficiency, low error rates, and better clinical decision support. Specialized AI is already proving valuable in many fields, from finance to manufacturing, aviation, and cybersecurity. Its success lies in leveraging the strengths of AI within tightly scoped environments where context, data, and objectives are clearly defined. In short, specialized AI is not about doing everything. It's about doing one thing exceptionally well. As we move forward, the principle of focused design will remain critical, especially as systems become more autonomous and more embedded in sensitive domains.
When we perform reasoning, we need some cognitive effort. Our reasoning could be transformed into an algorithm and then into a code, source code. This code could be saved in a file or in a library like Python library. This is very useful for the machine. But for me as a human being, if I would like to use some reasoning that I performed 6 months ago or 20 years ago, I have to do the reasoning again. I cannot insert my hand into my brain and take this reasoning as a code. This is not possible, but for the machine it is possible. So the set of codes that are available for the machine, in fact, they are a set of reasonings that the machine does not need to perform again. The machine needs only to use them in a certain place, to use them to solve solve a new problem. In other words, when the machine has to solve a new problem, part of it is done already by a previous reasoning which was materialized in terms of a code. This opportunity is not available for the human being. The human being needs to reason again on everything and to remember his or her reasoning. This presents a huge power of the machine. Again, the intelligence of the machine comes from these conditions. The fact that we can use a previous reasoning without doing it again is one of the elements of power of artificial intelligence.
Risks of Direction 1: Specialized AI, with software development as example. As we explore the future of artificial intelligence through these 8 strategic directions, it's essential to recognize that each direction carries its own set of risks. To keep our discussion focused, we will examine just one of these directions in detail: specialized AI. Specialized AI systems are designed to solve specific, well-defined problems with high efficiency. In software development, AI-powered tools can now translate algorithms directly into code, search online repositories like GitHub or Stack Overflow, and synthesize patterns from massive code bases to generate fast, reliable results. These tools excel in speed and consistency, often outperforming human programmers in routine and structured tasks. But this strength introduces a critical risk: the potential disappearance of traditional programming jobs. Roles such as software engineer, web developer, and application programmer may be significantly reduced or redefined. The risk manifests in several ways. Massive labor displacement. As companies adopt AI development tools, there may be less need for junior and mid-level developers. Deskilling of the profession. As AI handles more coding, fewer professionals will retain deep system-level programming skills. Misalignment between education and employment. Universities may continue training students for roles that are increasingly automated. This risk extends beyond individual careers. It affects outsourcing economies, global tech labor markets, and the balance of value creation in the software industry. In our framework of 15 performance conditions, this situation particularly concerns Condition 1, the role of the human creator is being redefined. Condition 12, AI evolves faster than the human labor force can adapt. And Condition 15, ethical and regulatory frameworks must respond to potential job loss and inequalities. In conclusion, while specialized AI delivers impressive performance, it must be integrated responsibly with attention to labor impact, skill transition, and long-term sustainability. This example illustrates the broader principle: every advance in AI brings new capabilities and new challenges. Managing these risks is just as important as achieving technical success.